We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
Godspeed, John Glenn.
Roger, 0G, and I feel fine.
Okay, my feet are out. Okay, I'm out. Really looks funny out there. See my glove out there, Jim.
Jimmy 4, good back yet. Good morning, Gordo.
Yes, how are you?
How does it feel for the United States to be the new record holder?
At last, huh?
By cooperating together in these new realms of infinity.
We have a liftoff, 32 minutes past the hour. Liftoff on Apollo 11.
Houston, Tranquility Base here. The Eagle has landed.
Hello and welcome. This is Michael Annis, and you're listening to episode 74 of the Space Rocket History Podcast. I recommend listening to episodes 71 through 73 before you listen to this episode. And now, Gemini VIII, Part 3. We ended the previous episode with Gemini VIII's rendezvous with the Agena target vehicle. For 36 minutes after rendezvous, Armstrong's delicate maneuvering kept Gemini VIII on station with the target. As Armstrong piloted, Scott inspected the Agena, checking antennas, docking lights, and other similar things. Finding it hard to see all of the target's instrument panel displays near the docking cone, he used the telescopic sight of a handheld sextant. But a really good look would have to wait until they were docked, when these instruments would become a second dashboard. Meanwhile, Armstrong studied the general appearance of the Agena. It seemed stable, and he nudged the spacecraft to within a meter of the target. Then, at 6:32, Capcom on the Rose Not Victor tracking ship radioed permission to dock. Armstrong eased Gemini VIII toward the target at a barely perceptible rate of 8 centimeters per second. Then Armstrong gleefully reported, quote, "Flight, we are docked. It's a real smoothie, no noticeable oscillations at all," end quote. For a moment, the flight controllers in Houston could not realize that they had really accomplished docking. Then pandemonium broke loose with backslaps, handshakes, cheers, and tremendous grins. Here's the clip.
After station keeping for 35 minutes, Command Pilot Armstrong begins to move in closer to Agena, preparing his final docking approach. Both vehicles are traveling at approximately 17,500 miles per hour. The command pilot makes a docking approach by applying very small thrust increases to Gemini VIII. The maximum velocity difference between the two vehicles at docking will be about 1 foot per second. When the command pilot is about 2 feet from the Agena, he will pause until he gets a go from the Rose Not Victor. The double check has been completed.
Okay, Gemini 8, we have PM solid. You're looking good on the ground. Go ahead and dock. I think we're going to hold off on this SPC thing until he does get docked.
Okay, go ahead with your memory compile.
Roger.
Let us know what you get out of that.
Flight, we are down.
That was it. 2 vehicles docked for the first time in space.
About this time, flight controllers started to suspect that Agena's attitude control system might be misbehaving. There had been some difficulty in verifying the Agena's uplinked stored program commands for the planned docked yaw maneuver and in loading the target's velocity meter. In fact, Jim Lovell on the remote link through Tenerife told the crew, quote, "If you run into trouble and the attitude control system in Agena goes wild, just turn it off and take control with spacecraft," end quote. With this warning raging in their ears, Armstrong and Scott began their docked chores. The Agena was designed to obey orders from the spacecraft, as well as from the ground. Scott commanded the target's attitude control system to turn the vehicle combination 90 degrees to the right. It took 5 seconds less than the full minute expected. Scott next dialed an order to start the Agina's tape recorder and looked over toward Armstrong. As he did, his gaze skimmed the control panel in the spacecraft. Something looked wrong. Gemini VIII should have been in level flight, but the ball indicator showed a 30-degree roll. Scott knew there was no use checking the horizon out the window as they were passing through Earth's shadow. There would be no help from the ground tracking stations either. They were still out of communications range. Scott said, "Neil, we're in a bank." Armstrong's attitude controller confirmed Scott's conclusion. Armstrong used bursts from the ohms to stop the motion temporarily, but it soon started again. The astronaut's immediate reaction was to blame the Agena. As soon as the vehicle was steady enough, Scott commanded the Agena to turn off its attitude control system as the communicator had instructed. For 4 minutes, the two spacecraft steadied and straightened up. The trouble seemed to be over. Armstrong started maneuvering to get the docked vehicles into the correct horizontal position. Suddenly, they began to roll again, faster and faster. The crew was supposed to do a small test to find out what stress and strain the linkage between the two vehicles could tolerate. That issue was now academic. The immediate question was whether it could stand up under these wild gyrations. While Armstrong struggled with the controls, Scott photographed the interaction between the two vehicles out of his spacecraft window. The command pilot soon reported that the ohms propellant had dropped to 30%. This was a strong clue that a spacecraft thruster might be causing the problem. While Armstrong fought the controls, Scott cycled the target vehicle switches off and on and off again. Then Armstrong jiggled the spacecraft switches as well to see if they could isolate the problem. Nothing they did seemed to have any effect. The crew realized that they would have to break away from the Agena to analyze the situation. Unfortunately, their ground-based simulation training gave them no clues to what was happening or how to handle it. Scott transferred control of the Agena to the ground stations, and Armstrong labored to steady the vehicle enough to separate them. "Go," Armstrong said, and Scott hit the undocking button. Armstrong gave the thrusters a long, hard burst, and the spacecraft pulled straight back. After separation with the Agena, conditions got worse. Almost immediately, suspicion about a spacecraft control problem became an established fact as the spacecraft rolled even faster. Gemini VIII soon came into acquisition range of the tracking ship Coastal Sentry Quebec. Capcom aboard the ship was concerned and perplexed. He could not get a solid electronic lock-on, but a blinking light signal indicated that the craft had undocked. Unaware that the ship was rolling so the antennas could not remain in position, he put in a call to the crew to try to find out about the strange signs he saw on his console. Here's the transcript. Capcom. Gemini VIII, CSQ, Capcom, Comcheck, how do you read? Scott. We have a serious problem here. We're tumbling end over end up here. We're disengaged from the Agena. Capcom. Okay, we got your spacecraft free indication here. What seems to be the problem? Armstrong. We're rolling up and we can't even turn anything off, continuously increasing in a left roll. Capcom. Roger. Gemini VIII, CSQ. Armstrong. Stand by. Scott. We have a violent left roll here at the present time, and we can't turn the reentry control system off, and we can't fire it, and we certainly have a roll. Stuck hand control. End of the transcript. After backing away from the Agena, the spacecraft had started to whirl at a dizzying rate of 1 revolution per second. Armstrong suspected that the maneuvering thrusters were almost out of fuel. He and Scott were also having trouble seeing the overhead panel dials. Their physiological limits seemed near. They were dizzy and their vision was blurred. Something had to be done. All that we've got left is the reentry control system, Armstrong said. Press on, Scott responded. The two men began to throw switches to cut out the ohms and maneuvering system and cut in the reentry control system. Armstrong tried his hand controller. Nothing. Scott tried his. Still nothing. They started switching circuitry again. Maybe something had been set in the wrong position. Finally, the hand controllers responded. Armstrong steadied the motion and then turned off one ring of the reentry control system to conserve fuel. He then carefully reactivated the maneuver thrusters. Now they were able to tell that number 8 had failed on. That is, it had stuck open. Here's the clip.
Gemini VIII, CSQ Capcom, contact Audi Reed. We got serious problems here with the controller coupling end over end and we're disengaged from the Agena. Okay, we get you a spacecraft 3 indication here. Take it. We're showing you spacecraft 3. What seems to be the problem? They're rolling up and we can't turn anything off. Signaling increasing in a left roll.
During the emergency, Armstrong and Scott had used all 16 of the reentry control system thrusters to counteract the violent tumbling and dampen out the roll. This maneuver succeeded in stabilizing the spacecraft at 6:06 p.m., but ended up using 75% of the reentry control system fuel. Using the reentry control thrusters meant that the Gemini VIII mission would have to come to an end as soon as possible. That was a mission rule. True, the spacecraft was operating in a backup mode, but it had to use the prime mode for reentry. If these thrusters developed leaks, the crew would have absolutely no means of getting the spacecraft into position for the critical retro fire that would return them to the Earth. Attitude control before and after reentry was essential to reenter the atmosphere safely. Here was a case when the fail-safe maneuvers that headquarters had insisted on early in the program were impossible. There was virtually no maneuverability left in the orbital thrusters. Armstrong and Scott also remembered that Kraft, the flight controllers, and the engineers had nursed other missions to completion. Could the same be done for them now? This was a fleeting hope, as the Hawaiian tracking station communicator told them to get their spacecraft into position for reentry. All plans for performing an EVA were canceled. Gemini VIII's problems were certainly the most frustrating of any Gemini mission to date. The flight control team's ability to respond to real problems on previous missions, keeping spacecraft flying to wring all the useful data from failures as well as successes, had bolstered confidence in the program and promoted real-time planning. But Gemini VIII's failure had forced the astronauts to resort to a last-ditch mode for attitude control before the ground crews had a chance to provide the options that might have allowed the flight to go on. John Hodge, in his first trial as chief flight director, now had only one choice left. Which contingency recovery landing area would be best? If he waited much longer, it would take a full day or 15 orbits for the crew to reach a splashdown point from which they could be quickly recovered. Since the orbital track had pressed westward, landing during the 6th or 7th orbit would have to take place in the Pacific Ocean. When the Landing and Recovery Division recommended a touchdown in the 7th orbit, Hodge agreed. Gene Kranz had dropped by to listen to the spacecraft and target docking. Since Hodge had been at the flight director's console for 11 hours, he and Krantz decided that the second shift should report for duty immediately, catch up on all information, and direct the final phases of the mission. Had the flight continued for the planned 3 days, re-entry would have taken place on Krantz's shift anyway, and he and his men had more practice in recovery procedures than Hodge and his group. Meanwhile, Navy recovery forces in the Pacific were swinging into action. A destroyer, the USS Leonard F. Mason, steamed at flank speed toward the expected landing point 800 kilometers east of Okinawa and 1,000 kilometers south of Yokosuka, Japan. Now I have an interesting NASA clip on standard versus emergency recovery.
Several days before Gemini 8 will leave the ground, the USS Boxer steams toward the primary recovery zone where the mission will normally end. It begins training its complement of officers and men in recovery operations. Instead of launching amphibious strike missions, the Boxer now launches helicopters for search and retrieval of astronauts. On board is the commander of the Western Atlantic Recovery Forces, known as Task Force 140.3. 2 ships, 6 helicopters, and 6 aircraft are assigned to this task force. All 5 manned Gemini flights to date have been recovered as planned in the primary zone. Still, 10 more ships, 54 aircraft, and 5,000 additional men will be deployed at different stations around the world for recovery. There are 9 other planned landing areas lying within the 3 major zones of the Eastern Atlantic, the Mid-Pacific, and the Western Pacific. In the Western Pacific, the USS Leonard F. Mason. The Mason will cover 3 landing areas within Zone 3. It will be backed up by aircraft from Okinawa and Japan. The chief difference between the primary area where the Boxer is stationed and a secondary area such as this is the comprehensiveness of coverage, the number of aircraft, ships, and recovery specialists on station. In addition, a special launch abort area covers the landmass and immediate offshore areas at Cape Kennedy. Recovery teams go out before the astronauts enter the spacecraft in case of an ejected abort from the launch pad or shortly after liftoff. There could be more extreme contingencies. The emergency might be such that a spacecraft could not land in a planned landing area. In a dire emergency, the command pilot might have to fire the retro rockets and come right down. Bare statistics come into play here. The world is 70% water and 30% land. The odds are strongly weighted toward a water landing. Aircraft are stationed at 12 points to locate the spacecraft in this emergency. Any commercial shipping in the area might then be called for assistance to pick up the astronauts. Freighters, oilers, tankers, any ship with heavy hoist equipment could also take the spacecraft aboard. If the crew comes down over land, they would use the ejection seats, leave the spacecraft, and land by parachute. Astronauts have not only a complete survival kit to sustain them, but they are trained to live off the land, even desert and jungle. Whether Gemini comes down over water or land, recovery is planned and coordinated by a NASA team of specialists. They set up the requirements for a mission and work closely with the Department of Defense. DoD then commits the necessary ships and aircraft to do the job. The DoD manager for manned spacecraft support directs worldwide recovery forces. He is in contact with 2 main elements under his command, the Atlantic Recovery Control Center, Cape Kennedy, and the Pacific Recovery Control Center, Hawaii. The red telephone puts him into direct contact with the highest levels of the Department of Defense for further assistance.
With Gemini 8 now flying over the southern latitudes, Gene Kranz had 3 tracking stations in position to keep in touch with the crew: Coastal Sentry Quebec, Rose Knot Victor, and Hawaii. The spacecraft was in darkness over the Congo when Kranz's Houston flight controllers began the final countdown for retrofire. Armstrong was worried that he and Scott might land in some remote wilderness where they would be hard to find. He wanted Scott to double-check his every move. Armstrong told Scott, "I keep thinking there's something we forgot about, but I don't know what it is." Scott answered reassuringly, "We've done everything as far as I know." Over China, Gemini 8 slipped down into the fringes of the atmosphere. Everything clicked off properly during descent. As they neared a landing, Armstrong asked his partner, "Do you see water out there?" Looking into the first faint light of dawn, Scott replied, "All I see is haze." "Oh yes, there's water, it's water." Less than 2 minutes later, Scott shouted, "Landing safe!" The flight had lasted 10 hours, 41 minutes, and 26 seconds. The crew went quickly through the post-landing checklist, putting switches and valves in their correct positions. Then antennas were extended so they could communicate with the recovery forces. Scott transmitted, "Naha Rescue 1, Naha Search 1. But no answer came. The astronauts were not worried, however, as Houston Flight Control had told them the rescue plans would get to them shortly and the Mason should reach them in 3 hours. This meant their landing had been very close to the contingency touchdown point. Several aircraft had raced to recover the crew, including 2 HC-54 Rescue Masters, one from Naha Air Base, Okinawa, and the other from Takikawa Air Base, Japan. The HC-54 from Naha got there first. Suddenly the pilot shouted, "I got it!" He had seen the spacecraft, with its main parachute in full bloom, drifting to the ocean's surface. 3 pararescuemen were equipped and ready to jump. Armstrong and Scott saw one of the 3 as he parachuted down. Because of the waves, the frogmen had trouble hooking the flotation collar to the spacecraft. The rough sea also made them queasy, a feeling shared by the astronauts. But the swimmers persisted and secured the collar within 45 minutes of spacecraft landing. Demonstrating excellent cooperation with NASA and careful planning, the Department of Defense Recovery Forces had reacted to the emergency landing as though it were normal. Armstrong and Scott had few complaints about recovery in this remote area. 3 hours later, as promised, the Mason pulled alongside and fastened a line to the spacecraft. Climbing the Jacob's ladder in sea wells of 4 to 5 meters was hard, but they made it. On deck, the tired astronauts managed smiles and greetings for the welcoming sailors. Still feeling nauseated, the Gemini VIII crew headed immediately for sickbay. Medical personnel helped them strip off their pressure suits. Their undergarments were soaked with sweat. They were thirsty, but clinical examinations showed minimal dehydration. The Mason reached Okinawa the next day, and the 2 astronauts flew on to Hawaii, then home. With the astronauts safe, the analysis of the events began. During the time of crisis, the engineers who had worked so hard on Agina's problems found their situation just as exasperating as that of the flight controllers. After docking, Smith, Harold W. Nolan, and others from Lockheed had retired to a nearby hotel room to celebrate the momentous event. Very shortly, Smith called Nolan, saying, "We've got trouble." Nolan switched on his television only to hear newscasters reporting that the Agena was at fault. Smith's motel room became the initial Lockheed Failure Analysis Command Post, the first guess being that the target's attitude control system had failed. Many other engineers and program officials also heard about the spinning spacecraft while out of touch with minute-to-minute developments. Mueller, for instance, had remained at Cape Kennedy only through launch and the early phases of the mission. Then he took off for Washington to attend the annual Robert H. Goddard Memorial Dinner. The pilot of the NASA aircraft heard what was happening over the plane's radio and informed Mueller. They returned to Florida immediately, where Merritt Preston met Mueller's party with a motorcycle escort to the old Mercury Control Center just in time for spacecraft retrofire. Most of NASA's leaders at headquarters had in fact already headed for the Goddard Dinner, the prestigious social event of the year for the space community. At the opening reception, Deputy Administrator Siemens was called to the telephone to learn of Gemini VIII's plight. He immediately phoned Houston Flight Control and learned that the spinning spacecraft had been stopped. When he told the chairman of the dinner about the trouble, Siemens was asked to make a brief announcement. He said the flight would have to be aborted, but the crew seemed in no immediate danger. Vice President Hubert H. Humphrey, the principal speaker, asked to be told as soon as the crew had been successfully recovered. Before he had finished his address, Humphrey was able to inform his listeners that Armstrong and Scott had landed safely. Siemens vowed that never again would he be caught in a public position during the critical phase of any succeeding flight. He needed privacy and better communications with the control center. As a rule, McDonnell sent several of its experts from the Cape to Houston after launch and first orbit to be available as troubleshooters. After the Gemini VIII launch, a NASA Gulfstream was dispatched from Florida for Texas with about 14 passengers, among them several high-ranking McDonnell engineers. Over New Orleans, the pilot cut in a commercial radio broadcast to the cabin. The announcer was talking about an imminent recovery in the Pacific. This was all the startled passengers heard. Since the news announcement ended there, something had obviously gone wrong, but what was it? There was nothing to do but wait until they got to Houston. As a result, McDonnell changed their policy so that in the future senior McDonnell officials, Hill, Walter Burke, John Yardley, and Robert Lindley, would not be in transit at the same time during a flight. Now let's move on to the status of the still orbiting Agena. Once the manned phase of Gemini VIII mission was over, flight directors Hodge and Krantz turned their attention to Agena. Fortunately, Dave Scott had the foresight to pass the control of the Agena back to the ground. Now there was a chance to test the Agena to see how it reacted to commands. There was still hope that the Agena for Gemini VIII might be used as a passive target for Gemini IX or X. After the undocking, the Agena had stabilized quickly. In the 15th orbit over the Carnarvon station, more than 21 hours after launch, Flight Control commanded the main engine to fire twice to place the Agena in a circular orbit 407 kilometers above Earth. The first burn produced its half of the goal, but the second burn did not. Instead, Flight Control found the orbital parameters were now 407 by 626 kilometers. Melvin F. Brooks, the Agena systems monitor in Flight Control, immediately began conferring with Lockheed engineers to figure out what had happened. They suspected that the vehicle's center of gravity had been miscalculated. The question was, how could they command the vehicle to offset this? On the next main engine burn, the center of gravity compensation attempt failed. Brooks and Lockheed engineers huddled again and agreed that there also seemed to be trouble in the yaw hydraulics, allowing the engine to gimbal more than it should. The target's orbit now measured 211 by 476 kilometers. If this Agena were to become Gemini IX or X's passive target, there were two major problems to contend with, and Flight Control had to decide what to do about them. There was definitely too much fuel aboard, and the orbit was still too high. Hodge and his controllers decided not to try any more plane change maneuvers. They would simply try to get the vehicle to the altitude they wanted. The next firing, a retrograde maneuver, convinced them that they had the hang of operating the vehicle. So Flight Control concentrated on reducing the fuel supply in both the primary and secondary tanks. In all, 10 maneuvers were made using the two propulsion systems, sometimes with both firing at the same time. This was considerably more than the 5 starts required by the contract. The Agena Command and Communication System had accepted a total of 5,439 commands. Lockheed's contract had only called for 1,000. Agena's solo maneuvers wiped away any suspicion of wrongdoing on its part, so the analysis returned to the Gemini spacecraft number 8 thruster. From its landing spot in the Pacific, the spacecraft had been hauled back to its place of birth, the McDonnell plant in St. Louis, so the engineers could analyze its problems. The spacecraft was checked over completely for more than a month. Their conclusion was The valves on thruster 8 stuck open because of an electrical short. To prevent a reoccurrence of the thruster problem, McDonald changed the attitude control circuit switch so that when it was in the off position, no power could go to the thrusters. Thus, the Gemini 8 mission was a partial success. On the positive side, the Gemini 8 crew achieved the first space docking, and during a time of crisis, the astronauts were recovered safely and the recovery network performed well. On the negative side, early termination of the mission prevented the achievement of many mission objectives, including the EVA. Of the 6 scientific experiments, only the Agena micrometeorite collection was successful. The others, zodiacal light photography, frog egg growth, synoptic terrain photography, nuclear emulsions, and spectrophotography of clouds were incomplete. It is contended by many that if the spacecraft had been over a ground station during the thruster failure, telemetry would have told Mission Control that thruster number 8 was firing continuously. Then Mission Control could have told the crew what to do before they activated the re-entry control system and used up their fuel. Thanks for listening to this archive episode of the Space Rocket History Podcast. If you are financially able, please support the podcast by going to the homepage, spacerockethistory.com, and clicking on the orange donate button or the Patreon link. Thanks.